the independent camshaft timing systems. And that means that we've advanced from simply controlling the exhaust cam to controlling all the cams on the engine. In this V engine, we can see there's a phaser for each exhaust cam and each intake cam. Of course, if we have an inline engine, there's going to be one exhaust and one intake. Variable camshaft timing uses oil pressure, the engine oil pressure. It uses that pressure to adjust valve opening and closing events. The phasing of the camshaft controls the angular position, and that's going to be in relationship to the crankshaft. So cam timing is changing the relationship of the camshaft to the crankshaft itself. Now this is going to allow for the timing of the valve opening and closing events to change or to be variable. This is going to help reduce emissions, give us power when we need it. And for light load cruises, we don't need a lot of timing advance. Let's look at a crankshaft position sensor in the blue on the top and a camshaft position sensor in the red on the bottom. And this is with no changing. We do not have any VVT, variable valve timing, variable camshaft timing, VCT, commanded at this time. This is the normal position for the cams. When we look at the holding position, nothing's happening. The cam did not change in relationship to the crankshaft position sensor. Make sure you understand we're looking at one camshaft here. It's not the intake, it's not the exhaust, we're just looking at a relationship between the camshaft itself and the crank. We could look at each phaser or each camshaft position sensor. When we have independent camshaft adjustments, we have multiple camshaft position sensors, so the computer knows, did the cam move where it was supposed to move to. Here we're looking at cam timing advance. The red arrow showing that we advanced here. Now what changed is the camshaft's relationship to the crankshaft. I'm going to go back. When we look at it back here, there is the camshaft falling edge of the waveform. It's going to move as the computer commands advanced timing. Then of course it's going to be in a hold position. Now you're looking at a static waveform. In the holding position, the cam is going to dither, and that means it's going to move back and forth ever so slightly. So once again, you're looking at a static waveform, not a live waveform, and we don't see any camshaft moving. But in live waveform, we would see it dithering or moving ever so slightly back and forth. So the holding position isn't really a fixed position. And right here we see where the cam timing was retarded in relationship to the crankshaft itself. I know I keep saying that, but that's what we're changing, the relationship between the camshaft and the crankshaft. Here, once it retards, it goes back to that holding position. Remember now, it's not fixed like it is here. It kind of moves around a little bit.